Okay, so guys, let's try our hands on this question here. That to evaluate the limit of this function as x approaches 0. So when you see something like this, the first thing that will come in mind is let's try direct substitution. But if you try direct substitution, you're going to have division by 0 and then that will be indeterminate. So you can't use that method to find the limit of this function here. Okay, what I'm saying is that if you substitute 0 in place of x here, then you're going to have 0 minus sine of 0, okay, divided by 0 cube, which is still 0, right? And then you know sine of 0 is 0, so then you're going to have 0 divided by 0, which is indeterminate. So you have to find a way to compute this limit. So what I'll do is that I will apply L'Hopital's rule. Okay, I will apply L'Hopital's rule. So let's look at how we're going to do it. So in applying L'Hopital's rule, all you have to do is to differentiate the terms in this function here. Okay, so we're going to have the limit as x approaches 0 times the derivative of x with respect to x minus the derivative of sine x with respect to x. Okay, all this divided by the derivative of s cubed with respect to x. So now let's simplify this. We're going to have the limit as x approaches 0. So now let's simplify the derivative. The derivative of x here will be 1. Okay, and then minus the derivative of sine x will be cosine of what? X. Okay, divided by the derivative of what? X cubed, then that will give us 3x squared. So at this point, let's try direct substitution and see what will happen. We're going to have 1 minus cosine of x, which is 0, right? Divided by 3 into bracket 0 squared. So you will have cosine of 0 is 1. So I'm going to have 1 minus 1 divided by 0. That will give us 0 over 0. So you see that you have indeterminate form again. So what you have to do is to differentiate the function again. So let's differentiate what you have again. So I'm going to have the limit as x approaches 0. Then let's find the derivative of 1. And you know the 1 is a constant, so its derivative will be 0. So I'm going to have 0 minus the derivative of cosine of x, and then that will give us minus sine of what? X, right? Divided by the derivative of 3x squared, and then that will give us 6x. Okay, so now let's simplify this. So I'm going to have the limit as x approaches 0 for sine of x divided by 6x, right? Let's try direct substitution again. So in trying direct substitution, I'm going to have sine of 0 divided by 6 multiplying 0. So we are going to have 0 on 0, which is indeterminate again. Okay, so what you have to do is to keep differentiating. So with L'Hopital's rule, you can differentiate as many times as so far as you don't get the limit. Okay, so let's continue from here. So from there, you have limit as x approaches 0 for sine x divided by 6x. Okay, I just rewrote what we have here. Okay, that's what I just wrote there. Okay, so now let's differentiate again. So when I differentiate sine x, that will give us cos x. So I'm going to have the limit as x approaches 0 for cosine of x divided by the derivative of 6x. That will give us 6. So at this point, let's try direct substitution again. So I'm going to have cosine of 0 divided by 6. You know, cosine of 0 is 1, right? Let's try that and see. Cosine of 0, that will give us 1. So I'm going to have 1 over 6. So therefore, this will be the limit of this function here. So one thing you have to know is that for L'Hopital's rule, you can differentiate the terms as many times as you want, so far as you've not been able to get the limit. Okay, so you can read more about L'Hopital's rule and then solve more examples for a better understanding. Please make sure you like and subscribe so that you can get notified when I upload videos. Thank you very much.